Hello students, today's contents are revision of superposition theorem, equivalent system of forces and its numerical. Okay, now the superposition theorem means what? Here in the system we can add or subtract a system which is in equilibrium. The effect of this force remains unaltered or means unchanged. So by this superposition theorem we can transfer a force from point A to point B. Okay, so with the help of that superposition theorem, now how we can transfer this force? Let's see that. Take first this system, that is AB is the beam, one force at point A which is vertically downward force, P is the magnitude of that force, and the distance of AB is D distance. Okay, now see, from we want to shift this force from point A to B, but without changing the effect of this system. Okay, without changing the effect of this force at point A. So how we can transfer that force from point A to B? So let's that we, by superposition theorem, let's assume that a system that is in equilibrium we can add or subtract in this beam or in this existing system. So at B point consider a system which is in equilibrium. Let's see this P force, vertically downward force, and this P force, vertically upward force at point B. So its resultant is 0, minus P plus P. So this is system is in equilibrium. So effect of this on this beam AB, only P at point A which is vertically downward. So we can add or subtract a system like this by superposition theorem. Now but here if we observe carefully, point A, one force which is vertically downward force P force, and at the point B one vertically upward force P. Okay, these two forces having the same magnitude, unlike parallel forces, non-collinear forces. So these two forces forms a couple. So in the second diagram, the effect of the force at point P is only one force, and this is nothing but a couple. Okay, P, and what is the moment of this couple? Couple's moment is magnitude of one of the force and perpendicular distance D. So at point B, one force like this and one couple is there which is having the magnitude P into D. Now here we transfer the force from point A to B. Okay, तो कैसे हमने ट्रांसफर किया from point A to B? Same with the same magnitude. P magnitude वही है, direction is same, but same as it is, and but the moment of this force P about the point P. Okay, now calculate that moment of this P force at B. So this force is rotating anti-clockwise and P into perpendicular distance D. So P into D. So how we can transfer the force from point A to B? So shift this force as it is with the same magnitude, with same direction, along with the moment of that force about that point where we shift that force. We want to shift that force. Okay. Now this first diagram is known as a force system, and last diagram is known as a force couple system because it's having the force with couple. Okay, now in the numerical that is given that transfer that force from point A to B. Okay, so कैसे हमें transfer करना है और shift that force or find a system which is having the equivalent couple system at point B. Like this question is asked. Okay, numerically is asked. So transfer that from force that is given in the system as it is with the same direction, with the same magnitude, along with the couple of that or along with the moment of that force about that point. Okay, now these two systems, first and last system, is also known as a equivalent systems. Equivalent conditions of for that equivalent systems are, how we can say that these two systems are equivalent. See, in the first system there are the three equations, summation fx, summation fy, and moment equation. So if first system and last system satisfied that three equations, these two systems are known as a equivalent system, or vice versa. If these two systems are equivalent, then these three conditions must be satisfied. Okay, that three conditions are summation fx of the first system is equal to summation fx of second system. So let's see that how it is satisfied. So summation fx of first system, if we calculate, there is no horizontal force, so summation fx of first system is 0. If we calculate the summation fx of last system, that is also 0, there is no horizontal force and couple, तो उसका summation fx summation fy होता ही नहीं है. So first equation is satisfied. Let's say second equation. Second equation, summation fy of first system is minus p. Here second system fy is also minus p, so that second equation is also satisfied. Third equation, moment about a point A. Now see, moment of this force about point A. This force is passing through the A, so its moment is 0. So moment of first system is 0. Now moment of second system about point A. Now this force rotates about point A is clockwise. Okay, so clockwise means minus p into perpendicular distance. So minus p into d, and one couple is there which is anti-clockwise couple, so plus p into d. So minus p into d and plus p into d, so equal to 0. Means third equation is also satisfied. So first system and last system is also known as a equivalent system. Okay, so let's see the numerical of this such type of equivalent system. And equivalent system conditions, remember that these three conditions: summation fx 0, summation fx of first system is equal to summation fx of second system. Similarly, summation fy of first and second are equal, and moments of first and seconds are equal about the same point. Okay, now see the numerical. A force of 100 Newton is acting on a bracket as shown in the figure. Determine an equivalent force couple system at point A. Okay, this is the first sub question, and in second sub question, an equivalent system consisting of a 300 Newton force at B and another force at A. Okay, now first we solve the sub question number 1. So what is asked in this system here? This diagram is given. One force is at point C, which is having the 100 Newton magnitude, and angle of that force with horizontal line is 30 degree. Now what is asked in the first sub question? An equivalent force couple system at A. This is the A point. So means we have to transfer that force from point C to point A. Okay, but directly कैसे transfer करना है? Say with the same magnitude, with same direction, but along with the force moment about point A. Now this is the inclined force. So for that inclined force, first of all split that force into horizontal and vertical component and then calculate the moment. So let's see. So splitting of this force, this is the x having angle, force having the angle 30 degree with horizontal line. So this is the x component and this is the y component. 100 cos 30, 100 sin 30. Okay, now calculate here. See, so equivalent force system at a point A. To obtain the force couple system at A, simply transfer the force without changing its magnitude and direction, but along with its moment at point A. So let's see calculation of moment. Okay, now see this vertical force 100 sin 30. Okay, it is rotating anti-clockwise. Okay, anti-clockwise, so plus 100 sin 30. This is the vertical force. So perpendicular distance is horizontal, and this is the horizontal distance from point A. This distance, horizontal distance, so 0.8. So 100 sin 30 into 0.8. Now this horizontal force component, 100 cos 30. So 100 cos 30 is this line of action, is this one, and this is rotating like this about A, anti-clockwise. So plus 100 cos 30, and this is the horizontal force. So vertical distance, this is the 0.5, vertical distance is the perpendicular distance. So 100 cos 30 into 0.5. Now simplifying this, we get the moment at A is equal to 83.3 Newton meter plus. So plus means that moment is anti-clockwise. So like this, So the solution in this sub question number 1 is like this: transfer this force from point C to point A as it is with the same magnitude, with same direction 30 degree. Okay, and along with this moment जो हमने यहाँ पे calculate किया. Now second sub question, what is asked in that second sub question? An equivalent system consisting of a 300 Newton force at B and another force at A. Means suppose this is the solution number 1, this is the equivalent system which is having another system which is having the consisting of 300 Newton force at B point, at this B point, and force, another force at point A. So let's assume that these two systems are equivalent. That is given in the numerical. So what is that? Given in the, assume one system consisting of 300 Newton force at point B. Okay, so only magnitude is given, direction is not given. We assume that that is in the first quadrant, which is having the angle theta with x-axis. Okay, and another another force at A as shown in the figure. Let's assume that this force P, that direction is also not given, magnitude is also not given, which is at point A. So if these two systems are equivalent, so we have, that means that is given in the numerical. So we have the three equations. These three equations must be satisfied by these two systems. So, and here we want to find out the value of P. It's alpha means its angle, and this 300 angles, direction of that force. Okay, we assume this system like this. If we get the answer positive, then our assumption is correct, otherwise it is opposite to that of the assumed. Okay, now let's see. First apply the equation number summation fx of first system and second system. Now first system summation fx is, this force is in third quadrant, so x component is minus 100 cos 30. Now this summation fx of second system, minus p cos of alpha, and this component x summation fx plus 300 cos of theta. Now here p, alpha and theta, three unknowns. We can't calculate that equation 1, or we can't solve this equation 1 for these three unknowns. Okay, we want three equations for three unknowns. So let's simplify this and equation number 1. Okay, then second equation, summation fy for first system and second system. So summation fy minus 10 sin 30, and summation fy of second system minus p sin alpha plus 300 sin theta. Okay, so simplified and write the equation number 2. Similarly, moment of system number 1, moment about point A. Okay, 83.3, because first force is passing through that A, so that's why moment of that force is 0, only couple is there. Okay, and second systems 300 cos of theta into 0.4. Okay, now 83 point, simplify this, and here unknown is only theta, to simplify that we'll get the theta. Now put this theta in equation number 1 and 2. So one unknown, theta, is removed, only p and alpha is unknown. So two equations, two unknowns are there. Now by simplifying that like this, two equations, and solve this equation number 1 and 2, then we will get the value of alpha 42.06 and p is equal to 397.04. So by these three conditions we get the three unknowns. So this is the equivalent force couple systems numerical. Okay, now next numerical is similar to that this is the solution of that, and this solution is given that p force positive, so assumed direction is correct, and this angle, all these are the positives, means assumed are correct. Okay, now another numerical is this one. You have to solve this numerical similar to first one, and these are the answers of that question. Okay, so we discuss in this presentation revision of superposition theorem, equivalent system of forces, and numerical. Thank you.